The easiest and fastest way to collect a lot of micrometeorites is to place a couple of very powerful magnets in the downspout of a rain gutter. Next time it rains, the rain will wash the micrometeorites off, which collect on the roof. As they pass the magnets, most of them are magnetic in nature, so they'll be collected by the magnets. Cleaning the magnets off can be a little bit of a pain, so if you put them in a plastic bag first, it'll help. Unfortunately, when I went to make this video, I live in Southern California and it hasn't rained in 7 months. So I climbed up onto the roof and hosed it down, starting from the very crown or the top of the roof and working my way down to the gutter. This works pretty good, but a lot of the water will slosh over the rain gutter and you may lose a few. But there are so many micrometeorites up there after 7 months that that's not critical. And if you're wondering just how many micrometeorites you can find, well, an average house with 2,000 square feet of roof surface, if you were to hose the whole thing off and collect everything that you could get from it, you could easily get thousands of micrometeorites. Now these are very small, but they are still meteorites and fairly easy to see. In this picture, I've pointed out 8 that are easy to spot, and if you look around you can probably pick out a few more that I missed. The micrometeorites are smooth spheres that stand out from the rest of the clutter that gets blown up on the roof. They're spherical because as they hit the upper atmosphere, they completely melt inside and out, and surface tension forms them into a sphere, just like a drop of water falling from a rain cloud. For size reference, if you're looking at this at the small default window that YouTube usually provides, the image is at about 70% magnification. The spheres range in size from 1/1000th of an inch in diameter up to about 7/1000th of an inch in diameter. Micrometeorites are much more common than large meteorites that you can hold in your hand, but they're very small, and that's the trade-off you get. There are some that can be up to 2 millimeters in diameter. Beyond that, they're no longer considered micrometeorites, but full-fledged meteorites. What determines how many micrometeorites you'll find on your roof is dependent, of course, on how big your roof is, but also how long it's been since it's rained. The average fall rate for micrometeorites is about 1 micrometeorite per square meter per year. Now that doesn't sound like much, but if you've got a roof like mine that was left unrained on for 7 months, the number builds up, as this image shows. Another way to collect them off a roof is to attach a string of magnets to a bar and drag it over the roof. The problem with this is that it's a little slow, but the advantage is that you don't have your micrometeorites wet, so they don't have to be dried, and it tends to come out a little bit cleaner. Let's take a closer look at a few that I've collected off my own roof. If this image doesn't look crystal clear, it's because the object is only 5/1000ths of an inch in diameter, and if you're using the default small YouTube window, you're looking at it at about 500 magnification. Here's another that's the same size. This little guy is only 2/1000ths of an inch in diameter. That's about the thickness of a sheet of paper. If it looks like it's not a perfect sphere, it is. It's just leaning up against another rock. This one's closer to 3/1000ths of an inch in diameter. It's a perfectly smooth sphere. The 2 little amber blobs are just some dirt that got stuck to it. Here's another one that's about 5/1000ths of an inch in diameter. One thing I need to emphasize is when you're looking at these through a microscope, and you do need a microscope to look at this, they look much better than what these images are showing. They're almost 3-dimensional and the detail is much greater. Here's the largest specimen I've found so far. This is a full 7/1000ths of an inch in diameter. This image is the pride of my collection. These were actually found by my granddaughter, Abigail Allison, and I'm very grateful to her. It's a nice pair, perfectly clean and perfectly smooth. The smaller spherical one on the bottom is about 3/1000ths of an inch in diameter. But the real winner here is the oblong one. Now, as I said earlier, surface tension tends to pull the molten globules together into a sphere. I think what happened with this football-shaped one is that it was spinning, and because it was spinning, it formed an elongated shape. This is very unusual. This is the only one like this I've seen, and I'm very grateful that Abby found it. Thank you, Abby. All of the micrometeorites I've showed you on this video are iron-based, and that's why they were attracted to the magnet. The fact is that the vast majority of micrometeorites are rocky-based and won't be picked up by your magnets. Also, a lot of them are not perfectly spheres. If they're slightly larger, they can take on a lumpy appearance and can be much more difficult to identify. But fortunately, there's enough of the iron-type spherical micrometeorites to make this an interesting hobby. All you need is a magnet and a little bit of patience and a microscope, and you can have a lot of fun with this, and it makes a great science project. So I hope you enjoyed this video, and as always, thank you very much for watching.